So hi guys, today I teach you what is algorithm. An algorithm is a finite set of instruction or a logic written in order to accomplish a certain task. It can also be written in any language or a flowchart, or you can also use a flowchart. Oh sorry, pseudocode. So what are the main characteristics or properties for an algorithm? It should have an input. Obviously if you have an input, you definitely have an output. Definiteness, fitness, correctness, it is a common thing for a theory purpose, but as you know, try to write your algorithm as simple as possible. That's all. So it is just a theory base. I can show you with an example. So in algorithm, how can we invent an algorithm? Mean to say that how can we know that we should use algorithm here, you should not use an algorithm? So first of all, we have some type of analysis. So there are two type of analysis when developing an algorithm. First one is prior and the second one is posterior. Sorry for the writing. Okay guys, as you know, we have two types of analysis. First one is prior and second one is posterior. So what is prior and what is posterior? Prior means we have some time of an assumption or an algorithm. We can run it over our assumption, so the result should not be exactly and the result should be approximately. So we write it approx. Okay, and we are independent. We choose any type of value we want to use, so we are independent. Okay, but in posterior we have to run a code on a hardware or a computer, so the result should be exact, because we know that how much time it required to run an algorithm on it, how much it have a space to taken by an algorithm while execution and while storing data on it. So it will be exact, and it is dependent upon hardware. Mean to say, if you run a code on a Pentium 4, it will take some time like 4 minutes, but that code will be run into a core i7, core i9. It will take only 1 minute or maybe in seconds. So it is dependent on machine, or it's depend upon approximation. So algorithm should use this approach. This is algo. So we are using this approach, so it will take less time, less resources, and we can do many things because we don't need hardware to run our code. We have approximation, mean to say the maximum time or the minimum time to run a code, and that is called time complexity. So here I give you an example of algorithm and with the code. So if we have step 1, step 2, step 3 and step 4. Step 1 we take a number, a variable a. Step 2 we take variable b, or we should read a, read b, and in step 3 we should do sum a plus b, and step 4 you should show the result. Okay, it is very roughly. As I mentioned, you can write algorithm in your own language. It doesn't matter. The most important thing is right now I am changing into a code. And how can I change into a code? First of all, I will use C language. As you know, it is the most used language in the world. So in C language, I have to first of all show integer type of data, variable a, variable b, and the third one variable is sum. Okay, I will declare 3 variables. Then I will scanf, mean to say I will take scanf and these 2 variables a and b. Okay, semicolon always. Then I will sum a plus b. Now the answer is lies in a plus b, and printf the sum. That's all. So as you can see, now you understand it. It is a very rough example, but I will teach you. You can, if you have a good algorithm, you can convert it in any language you want: Python, C++, Java, according to your need. Now how to measure algorithm performance? Algorithm performance can be measured into 2 characteristics, 2 terms, 2 properties, 2 things we need to know how efficient the algorithm is. First one is time complexity and second one is space complexity. And time complexity, it will take how much time it will take to complete an algorithm, and what is the maximum time to take it. Mean to say minimum to maximum time, and there are method to measure that, and it is known as asymptotic notation. I will cover it in next lecture. So what is space complexity? Space complexity mean how much space is required to run an algorithm. So we will go some detail in it. Time complexity is a way to represent the amount of time required by the program till completion, etc, etc, etc. So the main thing is minimum time possible to run. Mean to say that that is the minimum time and also the maximum time. Okay. And big omega, these things are I will teach you in next lecture. And the second thing is space complexity. It is a lot of things, but the main thing is space required by the algorithm in course of execution. But you can say that when you are writing a code, it will require a space to store your variable. So that space is known as data space. And environmental space means the space required to store the environment needed to resume the code. And instruction space means a plus b is our instruction, but you can merge three into a simple definition is space. So mean to say every space of algorithm is need from its start to its execution, and after execution you have to store it there. So the total space required for an algorithm you have calculated by approximate space complexity method. And I will teach you in this in next lecture, because it is what is algorithm lecture and the topic is what is algorithm. So I will teach you the algorithm, and it is the crux of the algorithm. If you know that, anything you can do with algorithm, because if you have a strong base you can build any type of building on it. So have a nice day, guys.